Welcome, fellow stargazers, to a journey that will challenge everything you thought you knew about the universe. I'm Ray Tayson, and tonight we're diving into the cosmic weirdness that lurks out there. We'll explore 8 of the strangest, most unique stars astronomers have ever found. These aren't your average points of light. They're cosmic oddballs, each with a jaw-dropping story. From stars that spin like pizza dough to those glittering with diamond hearts, this is a stellar lineup you won't want to miss. Ready to have your mind blown? Let's get started. Let's kick things off with Achernar, a dazzling blue-white star nestled in the winding constellation of Eridanus, the celestial river. If you look up on a clear night in the southern hemisphere, you might just spot this cosmic marvel shining brightly, marking the end of the river's flow across the sky. Now, picture a star spinning so rapidly that it's literally squashed by its own speed. Its equator bulges outward, much like a pizza chef tossing dough high into the air and watching it stretch and flatten. Achernar is the ultimate cosmic pizza, spinning with such intensity that its shape is dramatically distorted. Achernar is a true heavyweight, tipping the cosmic scales at over 14 times the mass of our Sun. But what's even more mind-blowing is its equatorial speed, over 225,000 kilometers per hour. That's fast enough to travel around the entire Earth in less than 7 minutes. This breakneck rotation makes Achernar one of the flattest stars astronomers have ever observed. Instead of being a perfect sphere like most stars, it's noticeably squashed at the poles and stretched at the equator, a shape known as oblate. But the surprises don't stop there. Because of its rapid spin, Achernar's poles are much hotter and brighter than its equator. This effect, called gravity darkening, happens because the star's gravity is stronger at the poles, pulling material in tighter and making those regions hotter and more luminous. If you could somehow hover above Achernar's pole, you'd see a star that's bluer and hotter than if you were floating above its equator. The difference is so dramatic, it's almost like looking at 2 different stars depending on your vantage point. So, why is Achernar spinning so wildly? Astronomers believe its incredible speed comes from both its chaotic birth and the gravitational influence of a nearby companion star. This close neighbour tugs on Achernar, keeping it spinning at dizzying speeds and possibly even speeding it up over time. All this spinning isn't without consequences. Achernar is actually shedding some of its own material, flinging hot gas out into space and forming a faint glowing disk around itself. This disk is made of superheated gas, swirling around the star like a halo. It's like a cosmic pizza toss, except instead of flour and cheese, Achernar is tossing out streams of hot plasma and gas, creating a deadly beautiful spectacle in the depths of space. So next time you enjoy a slice of pizza, take a moment to imagine Achernar, the spinning cosmic pizza, twirling away in the universe, reminding us that even the stars can have a wild, delicious side. If you think Earth's diamonds are impressive, just wait until you hear about a cosmic gem that puts every jewelry store to shame. Diamonds on Earth may be rare and precious, but out in the universe, there's a diamond so massive and extraordinary, it defies imagination. Meet BPM 37093, affectionately nicknamed Lucy, the universe's ultimate jewel, floating serenely in the constellation Centaurus, about 50 light-years away from us. Lucy is a white dwarf star, the dense, cooling remnant of a once bright sun. At its heart lies a core of crystallized carbon, a diamond so gigantic, it weighs nearly 10 billion trillion carats. That's a number so big, it's almost impossible to picture. Imagine proposing with a diamond like that. Talk about cosmic romance. It would be the ultimate symbol of love, shining brighter than anything you could ever wear on your finger. Lucy is over 4,000 kilometers across, about the size of our moon, making it, quite literally, the most extravagant engagement ring in the universe. No jeweler on Earth could ever compete with this celestial masterpiece. And here's a mind-blowing thought. Our own sun will one day share this fate. Billions of years from now, after it exhausts its fuel, it too will shrink and crystallize into a diamond core, joining Lucy among the galaxy's most dazzling relics. But Lucy isn't just a pretty face in the cosmos. For astronomers, it's a scientific treasure, helping them unlock the mysteries of how stars live, die, and transform over billions of years. By studying Lucy's rhythmic pulsations, scientists can actually hear the music of this cosmic diamond, decoding its internal structure and learning more about the life cycles of stars. Lucy proves that when stars die, they sometimes do it in style, leaving behind a sparkling legacy that outshines anything we could ever imagine here on Earth. Next up, My Camelopardalis, a stellar duo so close they're sharing a cosmic blanket. In Camelopardalis, two massive stars orbit so tightly their atmospheres have merged. With a combined mass over 60 times our Sun, they're only 13 million kilometers apart. Their intense gravity distorts them into teardrop shapes, mixing outer layers in a never-ending cosmic waltz. These stars are literally inseparable, but this closeness comes at a price. Astronomers predict they'll merge in a massive supernova, outshining whole galaxies for a moment. Until then, they keep up their nightly dance, glowing with the energy of a million suns. In space, intimacy can be explosive. My Camelopardalis, the universe's most dramatic couple. Time to put on your dancing shoes, because we're about to take a trip to one of the most electrifying corners of the cosmos. AR Scorpii is throwing the universe's wildest light show, dazzling astronomers and stargazers alike with its spectacular cosmic performance. Nestled in the constellation Scorpius, this extraordinary system features a red dwarf star and a rapidly spinning white dwarf pulsar, locked together in a mesmerizing orbital dance. Imagine two stars orbiting each other, one of them spinning so fast it completes a rotation every 2 minutes. The white dwarf acts like a cosmic DJ, blasting the red dwarf with intense beams of energy every 2 minutes, just like a strobe light, but on astronomical steroids. These beams are so powerful, they light up the system in pulses that can be seen from Earth. This relentless energy barrage causes AR Scorpii to pulse with light in a rhythmic, almost musical pattern, creating a spectacle that's both beautiful and mysterious. It's as if the entire system is grooving to its own cosmic beat. What makes AR Scorpii truly unique is that it's the only known system where a pulsar's beams directly energize another star, turning the red dwarf into a glowing, flickering partner in this interstellar dance. By studying AR Scorpii, scientists are unlocking secrets about how magnetic fields and high-energy particles interact between stars. It's a living laboratory for understanding some of the universe's most extreme physics, helping us learn more about the life and death of stars. So, next time you think your neighbour's music is loud, spare a thought for the red dwarf, caught in an endless, inescapable rave, bombarded by energy pulses that would put any nightclub to shame. AR Scorpii, the universe's ultimate dance party, where the lights never stop and the beat goes on forever. In Cygnus, Tabby's star, KIC 8462852, has astronomers baffled. Its light dips unpredictably, as if someone's flicking a cosmic light switch. Some even wondered if aliens were building a giant Dyson sphere to harness its energy. More likely it's dust or comets, but nothing fully explains its bizarre behaviour. Tabby's star remains a mystery, inspiring debates, research and memes. Whether it's aliens or dust, Tabby's star keeps us watching and wondering. Meet WR104, a Wolf-Rayet star with a supervillain streak, about 8,000 light-years away. It blasts out streams of X-rays and gamma rays. Think comic book death ray, but real. WR104's powerful emissions come from its unstable, mass-shedding nature. Thankfully, Earth isn't in the crosshairs. We're safely out of the blast zone. Its pinwheel-shaped dust cloud, formed by a binary companion, makes it one of the galaxy's most photogenic stars. The universe has its own arsenal of death rays, but most are pointed somewhere else. Let's zoom out and talk about Wolf-Rayet stars in general. These rare, dramatic stars are massive, hot, and rapidly losing mass through intense stellar winds. Their outer layers are blown away, revealing hot, bright cores. They burn through fuel quickly and often end as spectacular supernovae or gamma-ray bursts. Wolf-Rayet stars can form beautiful nebulae as their winds shape the interstellar gas. Their tempestuous lives make them the ultimate scene stealers of the cosmos. If you want cosmic drama, Wolf-Rayet stars always deliver. Now let's visit SAO 26462, a young star surrounded by a stunning protoplanetary disk. Its disk is so structured, it looks like a miniature spiral galaxy swirling in space. Astronomers think infant planets are sculpting these elegant spiral arms. Studying this disk gives clues about how planetary systems, including ours, form and evolve. Some stars just flaunt their cosmic fashion, turning heads across light years. SAO 26462, a star with a spiral disk that puts even the Milky Way to shame. Thanks for joining me on this journey through the universe's weirdest and most wonderful stars. I hope you found some new cosmic favorites and a sense of awe. If you enjoyed this adventure, subscribe for more cosmic curiosities. Each week we'll dive into the mysteries of space and the wonders that light up our night sky. Until next time, keep looking up, stay curious, and let the cosmos inspire you.